Hi, good evening. Today we're going to be reviewing generics and exceptions in Java. This is something I do periodically throughout the semester. I get on camera here, and for about an hour or so, I either recap the last week's material or I give you a little preview of what's coming up next week. So this week or tonight, we're going to review generics in Java, how to turn a class into something that can hold any type of thing. And also we'll talk a little bit about exceptions. And exceptions are things that your class can throw out if some kind of error occurs. And that allows the user of your class to be able to receive or catch that exception and do something with it. Okay, so let's start out with, I want to do kind of like the simplest possible case, which is I've got a class here called box. And the idea behind the box class is it's just going to be a class to hold something. So maybe we'll have this class hold a string, and let's call it value. Okay, so my class is going to hold a string, and I made it private here so that users of the class can't go in and look at the value. And then I need a constructor, so let's call this box. And the constructor, let's say, is just not going to do anything except maybe set the value to be null. So initially the box doesn't hold anything. And then we're going to need a couple more methods. We should have one called set that's going to take in a string, and then it's going to assign that string to the value inside the box. So we'll say value equals v. And then finally we should have a method called get that allows us to look inside the box and see what's there. And so that's going to return the value that's inside the box. Okay, so just to recap here, we've got a constructor called box that initializes the box to be empty. We've got a method called set that takes in a string and assigns it to the value. And we've got a method called get, one that returns the value. Okay, so there's my class, and we see that it compiles just fine. And then we'll go over here to the code pad in BlueJ. Now, I love BlueJ because it allows you to just type in some code on the code pad without having to go through the whole process of making a main and looking at some output by printing it out. So we'll just go box b equals new box, like this. So now I've got a box called b, and I can look inside of it. I can go b.get, and it says there's nothing in it. So there's a null in there. And I can go b.set, and here's where I can put something in there like hello. And then look inside it, and I see that there is a hello inside there. And we can set it again. Let's set it to bonjour. And I can see that I've changed it now to a string. All right, so that's the idea behind this box class is I've got a class that just holds a string, and I can set it and I can get it. Maybe something that I could do to improve this a bit is I could add another constructor. This one takes in a string and assigns it immediately to the value. So the idea here is that I could construct a box and I can immediately put something into it. Okay, compile it. Looks good. Go over here and I can go box b equals new box, and I could pass in a value right away. And I can see I've got hello in there. And I can also create another box. Let's say c equals new box. And this one doesn't have anything in it, but I can set it. c.set bonjour. So I can look inside of box C and see that bonjour is in there, and I can look inside of box B and see that hello is in there. Okay, so I got two different boxes. They're independent of each other. They each hold their own string, and they have their own set and get methods. All right, so that's all fine and dandy, and now I have this box that holds strings, but what if I want the box to hold, let's say, a number? Okay, so I would have to change this to be int, and I would have to change the constructor to take in an integer. Now the body of the constructor doesn't change. I'm still assigning a value straight across. set would need to take in an int, and it still returns nothing. And then get would need to return an int. And then over here in this constructor, I can't set the value to be null because null is not a valid integer. So I have to do something like make this a 0. Okay, now it compiles. And now I've got a box b equals new box. And I can put the number 5 in it. Okay, and I see that the 5 comes back out. Box c equals new box. Let's make that empty. So get returns 0, and then I can set it. Okay. And then, of course, since this box doesn't hold strings anymore, if I try to set box B to be hello, I get a type error. It says that I'm trying to pass in a string, but it's assuming or it's expecting an integer, and the two can't be converted from one to the other, so I get a type error. All right, so let's put this back to be string. And this would be null. And this is string here, and string here. And perhaps you can see that if I wanted to make a box that held dogs, for example, I would have to change that to be dog, the argument to the constructor to be dog, the argument to set to be dog, and the return value from get to be dog as well. So everywhere basically I have string, I'd have to replace that with dog. Another possibility, and I'm just throwing this out there, is rather than having one class where I'm always recompiling it to hold different values, I could maybe have a variety of different classes. Like let's just do a copy here, and then I can make a new class. I could call it box of int. Okay, and I paste that in of int there. And this is int box of int of int. This is 0 int int and int there. Okay, so now I have one class here called box that holds strings, and I have another class called box of int that holds integers. And now this is maybe one way to maybe make a box that can hold a variety of things. But you can see how this doesn't scale up really well. If I then want to make a box of dogs, I have to make a whole new class for that. And you know what I'm really getting at is there ought to be a way, and there is a way, to make one class be able to hold anything that you put into it. So let's get rid of this one here. We don't need this anymore. Remove. Gone. So you can see that everywhere where I had string is where I had to do a little search and replace to replace it with the type of thing that I actually want to store. And when you see that sort of thing as a programmer, you're thinking that ought to be a variable. I ought to be able to put a variable there and give that variable a value with a type, and that'll be the thing that my box stores. And that's pretty much what generics in Java lets you do, is turn this type of string into a variable and then give the variable a value when you instantiate the box. So here's how we're going to do it. First is we're going to replace the string with a generic variable name. And usually, but the convention in Java is to use a single capital letter, like T for type or X, something like that. Let's use T. So what this is saying is that the box is going to hold a value, but the type isn't determined at this point. It's just a placeholder. It's going to be something. And then this is a T, this is a T, and this is a T. So everywhere we had string before, we now have T. And then up at the top, inside of angle brackets, we'll put T, which says that syntactically what we're saying is that when we construct a box object, we have to pass in a value that'll be assigned to T. And then throughout here, everywhere where we see T, it's going to be replaced with whatever value we gave it, like string or integer or something like that. Okay, so if we compile this, we can see no errors. Compiles just fine. But then to create our box, we're going to do it like this. Box, and then in angle brackets, we're going to put in the type that we want to assign to T, like string. B equals new box string parentheses parentheses. Okay, so this is the same object creation statement we had before. There's just two new additions. They're both the same. It's this type inside of the angle brackets right after the class name. Okay, let me make it a little more clear. Let me take away the angle brackets and show you. This is what we had before, right? Box B equals new box, right? And that made a box of strings we had before, or integers. So all we're doing right now is adding in angle brackets right after the class name. And here where we're calling the constructor, it goes right after the class name and in front of the parentheses. And you can kind of remember where it goes because you see in the class definition, the angle brackets go right after the class name. Okay. Okay, so now I've got a box, and the value of t throughout the object is going to be string. So my box can hold a string. I can set it to hello, and then see what's inside it and see that it in fact is the string hello. If I try to pass in a number, I get an error. It says that int can't be converted to string, which is telling us that set is essentially expecting a string, and we tried to pass in an integer, and there's no way to convert them directly in Java. So this is a good thing. We've now made a box whose runtime type, the thing that it can store, has been set by us, the user. And the compiler will catch these errors if we try to pass in the wrong thing. Another example would be, let's make another box, but let's have it hold something else. Let's have it hold JFrames. Okay, remember JFrames are windows in Java. They're just an object, just like any other thing. So I can do something like import javax.swing.jframe. Okay, and then I can go JFrame window equals new JFrame, and I've just made a window. You can't see it on the screen because it's invisible, but I've just made a window called win, and it's of type JFrame. Okay, but now if I go b.set win, if I pass in that window into my box, we'll see it doesn't work because it's expecting it to be a string, and we're trying to pass it in a JFrame. Okay, but I could make a box that holds JFrames. Right, so I could go box of JFrame. Right. Let's call it C equals new box of JFrame. Okay, and then I can go C.set win, and now I've put that JFrame object into my box. And if I say get, well, I can't see the window here in my code pad, but it does come up and say that whatever get returned, it's a JFrame. I can also say is c.get equal to win. So is the thing that get is returning, is it the same thing that win is? And it says, yeah, that's the same thing. So I know that what is coming out of the box is the same thing that I put in. And I'm not sure if this will work here. Let's go win.toString. All right, well, that's not really what I was expecting. But this is basically saying this is the string representation of a window. It's this big long thing. Okay, now what I'm going to try here is if I go c.get.toString, I'm hoping that I get exactly the same thing back, and it looks like I do. So I'm pretty confident that what get is returning is the same thing that win is. So it's the same window. All right, so that's how to make a class generic. You find everywhere where you refer to the thing you were storing, like string, and you replace it with a variable name. By convention, it's a single letter. It can be anything you want, but it's a single letter. And then after the class name in angle brackets, you put in that single letter, and it's almost like you're passing in an argument to the box. All right, so that's the basics of making a class generic. Now, let me tell you about some caveats here. So just because you've made a class generic and because the compiler is enforcing the type checking when you try to use something like get or set, what's actually going on behind the scenes is a little strange. See, Java generics was introduced, I think, in Java version 5, if I'm correct. Maybe it was 4. Anyway, so there were all these versions of Java, 1, 2, and 3, and possibly 4, that existed and had no idea what generics were. And then this new syntactic thing was introduced in Java 5. But in order to preserve what they call backwards compatibility so that new programs would still run on older Java runtime environments, is they had to pull a little trick called type erasure to make generics work. And what's going on behind the scenes is everywhere where you have T, it's actually, again, behind the scenes, replacing it with the type object. Okay, so this is what's sort of really happening back there. Okay, so our box actually just holds objects. And if you remember from maybe a previous course in Java, there's a type hierarchy in Java. So every class you create, it extends or inherits from another class. And you can work your way all the way up this tree. And at the very top of the tree is this class called object. And all other classes in the Java system are descendant from object. So object is this superclass that everything is related to. So it means that I can create a box that holds objects, and no matter what I put into it, it'll hold it. So if I compile this, it works fine. Now, I've ungenericized it, right? I made it not generic here. It's just going to hold objects. But now I can go box b equals new box. Okay, I have no generics here, so there's no angle brackets involved. And then I can go set it with hello, and it takes it just fine. And I can retrieve it and see that I get the hello back out. But then I can set it with like 5. And, well, okay. But so notice here, first of all, it didn't complain that when I put a string in first and then I put an integer in later, it was just fine with that. I'll skip this for now and get back to that in a moment. But let's put in like let's go import javax.swing.jframe. Okay, and then we'll go jframe win equals new jframe. Okay, and then I can go b.set win, and it takes it. So my box, which is not generic but holds objects, will basically take in anything I give it and let me put in there whatever I give it, and it will gladly give it back. So if I say b.get, I get back a JFrame. Okay? So this is good and bad. It's good because now I've got a box that can hold pretty much everything, but it's bad because from a programmer's point of view, this can cause errors in my program because I've got this thing, a box, which I want maybe to hold just strings, and it will accept anything I throw at it. So from a programmer's point of view, you want to catch as many errors as possible before you run your program. You want to catch it while you're compiling the program. And this version of Box will basically not catch any errors at all. I can throw anything I want into it, and it will gladly take it. So when we put in the generics here, let's put the T back. Okay, because of that type erasure I was talking about, where behind the scenes it's taking that T and replacing it with object. If I create a box and I don't use the angle brackets, I don't use the angle brackets at all, even though I've made the class generic like this with the T, what I'm essentially doing is I'm saying, don't give T a value. Don't give T a value. And so what Java does behind the scenes, it goes, okay, since T doesn't have a value, I'll just swap in object for you. So this becomes object, that becomes object, that becomes object, that's object, that's object. So it goes back to essentially the version that I had written before. And now, just like before, I can put hello in there, and it takes it. and I can put in the number 5, and it takes it. Okay, now I'll explain what this is here is, since my box can only hold objects, I put the number 5 in, and what comes out is an integer object, which I can't directly inspect. However, I can cast it to int, and then I get the 5 back. So I get this integer object out, and then I can cast it to int, and then I can see the value. So now I can see that, in fact, there is a 5 inside of that box. Okay, so just because you make a class generic doesn't mean that the compiler is always going to catch errors for you. When you make a class generic, you have to remember to use it in a generic fashion with the angle brackets anytime you want to catch these errors. So nothing will stop you from forgetting to put in the angle brackets. So you need to remember to do them yourself. Box of string, C equals new box of string, parentheses, parentheses. Now that I've given T its value, it will go ahead and start checking the types for me. So C.set 5. You see, I'm going to get an error there. Okay, so you have to remember to use the angle brackets to give it that value for the generic type. Otherwise, it will just treat it as object and will gladly accept anything you throw at it. Okay, so on to something a little bit different here. So that's basically the idea about how to make something generic, right? You put in the brackets here, you do a search and replace throughout to find everywhere where you were storing a concrete type before, you replace it with this generic variable. And then when you create your objects, don't forget to put in that type inside of the angle brackets so that it knows what value to give to that T variable inside of your class. Okay, so I've got a box that holds one thing, one value. I now want to make my box hold multiple things. All right, I want to hold a variable number, so an array basically. I want to make a box that holds an array. That's what I'm getting at here. So instead of one single value, I want to hold an array of values. So you go, okay, well that's fine. Let's just make this an array, right? An array of T, and let's make my constructor just put in the value into box number 0. And set here, what we're going to do with set is, let's say we're going to give it an index and a value. And get, we have to give it an index and it retrieves the value there. Okay, for now, I'm not doing any kind of error checking at all. I'm just simply saying that what we have to do here is we have to go value equals new T, and then we have to give it a size, like let's say this thing holds 10 things. All right, so this is a pretty straightforward transformation of the box from holding one thing to holding an array of things. So instead of holding one single T, it now holds an array of T's. And then in my constructor, I say, make me a new array of T's that hold 10 things. Actually, this constructor is not going to work. Let's just get rid of this. Okay, I'm going to make the example a little bit easier. Get rid of that one there. And then my set, I'm going to give it an index and a value, and then it's going to put that value into the array location given by index, and then get does the reverse. It looks into the array and pulls that value out. Okay, so it looks pretty straightforward. If I compile it, I'm going to get an error. It says generic array creation. And honestly, I don't know why the creators of Java chose it to do this way, but basically, single variables like we had before, without the brackets here, support this idea of type erasure, where you can replace the T with the word object. For some reasons that honestly is a little fuzzy to me, actually not a little fuzzy, a lot fuzzy to me, arrays don't support that. You cannot make an array whose type T is unknown at compile time. The compiler needs to know what type of thing is being stored in the array at the time you hit the compile button. And in this case, we don't know what it is. So there's a little workaround we have to do to make it work. And that's to, how should we say, beat the compiler at its own game. The compiler, remember, is going to replace t by object. So let's go ahead and do that for it. We'll do that right away. Okay, so now we're going to say, instead of making an array of t whose value is not known when I hit compile, I'm going to put in object there and say, make an array of object whose type is known at compile time. It's going to be object. So I go compile, and it says, whoa, we can't, so this is a good thing. It's not giving us the old error before about not being able to create the array. Now what it's saying is you got a type conflict here. And so the answer there is, okay, I'm making an array of 10 objects, but you want it to be an array of t. All right, I'll cast it. So this is just a cast out in front. This says, take whatever thing is being returned by new, which is an array of objects, and make it an array of t. And now the types match up. Okay, I'm not changing what actually gets stored inside the array. It's still going to be an array of objects. I'm just making the types fit together correctly. Okay, compile it, and it compiles. Okay, this is just a little trick you have to do to make it work. You have to make an array out of a concrete type, a type that's known at compile time, in this case object, and then cast it to be our generic type t. So this is just a cast. You've seen these casts before. I'm just going to throw in some code here. You've probably seen a cast like double x equals int 5. Sorry, this is terrible here. Double 5, right? So this is just taking the value 5 and casting it as a double so that the assignment will work better, will work correctly. Okay, this is just a cast here. Inside parentheses, you put the type inside, and then it makes the types match up. All right, so this compiles, and now we're going to go box of string, b equals new box of string, and then b dot set, and then array element 0, hello. No complaints there. B dot set, let's put in 1, let's put in goodbye or just bye. And now I can say, show me what's in element number 0, and it's hello. And show me what's in element 1, it's bye. If I say, show me what's in element number 2, it's going to get a null because I haven't stored anything in that array location. All right, now if I attempt to go b dot set into array location 0, the number 5, I'm going to get an error. Trying to put an int where a string is expected. If I try to put that 5 into box number 2, which hasn't been set yet, I'm still going to get an error because that entire array is expected to be nothing but strings. And so again, from a programmer's point of view, this is a good thing because it's protecting me from accidentally storing the wrong kind of thing into this array, into this box. It expects only strings, and so will only expect strings. If I want to store just integers, I would say box of integer in all caps because I need to use the object version of integer. C equals new box of integer. And now I can go c dot set, put the value 5 into element number 0, and it accepts it. Let's see what's in there. Oh, let's cast it to an int so we can actually see what's in there. So that's number 5. And then if I try to put, let's say, hello into element number 1, I get an error because it expects only integers and I'm trying to pass it a string. Okay, so just to recap on the generic array creation, you need to create an array of object and then cast it to be the array of type t, the unknown type, in order to make the types match up. Okay, otherwise it's a pretty straightforward transformation to put array notation everywhere where you expect it. This is the only place where you have to do something a little bit, for lack of a better word, tricky to make it work. Okay, now you might do this and try it out yourself, and the compiler will actually throw a warning about unsafe type collections. In BlueJ, you can go to the preferences and I think it's under miscellaneous, and you can uncheck this box so it doesn't show you compiler warnings when unsafe collections are used. Basically, the reason why this is called an unsafe collection is for reasons that I alluded to a few minutes ago, where I could create this box B equals new box. And now it will happily let me put whatever I want into it because I didn't give t its value. So let's put 5 into slot number 0, and let's put hello into slot number 1, and it takes them both, right? So that's why this is called an unsafe collection, because it's possible to use it in a way that's not type safe, not safe for the programmer. So that the compiler generates this warning to let you know this is possibly happening. You can just uncheck that box to say, I don't want to see those warnings. There's actually another way to annotate your code so that the compiler won't show you the warnings at all, whether or not that box is checked. And I think it's something like at suppress warnings unchecked, something like that. Yeah. And now what this means is that anytime I compile the class, this method here, this constructor won't generate that warning because I've told it, don't show those warnings. Okay, but I'm going to leave that out because we don't need that. Okay. All right. So now we're on to exceptions. All right, so here's the problem with our box. Let's go box of string b equals new box of string b dot set 0 hello. That's fine. But if I go b dot set, let's say 15, I'm going to bring the window up so you can see it. I get an exception that says array index out of bounds exception on number 15. So I tried to pass in a 15 and I got an array index out of bounds exception. So what Java is doing here is saying you did something that was unexpected, and it's going to throw or lob at you this thing called an out of bounds exception. And the reason why we have exceptions is because normally a method like let's do get. Let's like get like 12. Okay, again, that's going to throw an exception right here. So get, the method get, if I bring up the code here, is supposed to return a thing of type t. But in this case, because I was trying to retrieve element number 12, get didn't actually return anything at all. Instead, it threw at us this exception to say something went wrong. And I, as the user of this class, could catch that exception and then do something with it, like maybe reprompt the user to type in something, or maybe allocate more memory, create a new box that holds more slots, something like that. So there's basically kind of two things that a method can return. It can either return the expected value, like a string or an integer, or it can lob or throw an exception to indicate that something went wrong. Okay, so we can do this as well, right? So they're built into Java. There's this thing called java.lang.arrayIndexOutOfBounds and we can make our program throw exceptions as well. So like, let's look at get here. Okay, so we really can't accept any old index. We can only accept indexes between 0 and 9, so they'll fit inside of our 10-element array. So we should do something like if index is less than 0, or index is greater than or equal to 10, we'll say throw new java.lang.arrayIndex out of bounds, I guess really long, exception. Okay, array index out of bounds exception is a class that exists within the Java system. It's a class. So to throw an exception, we need to make an object out of it by using new, and then we put the keyword throw in front of it to say we're going to generate this exception and give it back to the caller. Okay, so that's how you generate an exception. You find the name of the class, array index out of bounds exception. You use new to create a new object of that type of that class, and then you use throw to throw it out there. And I'm using the whole name here, java.lang, so that I don't have to, at the top of my code, go import java.lang.array index out of bounds exception, right? And then here, I could take that out and it will compile just fine. It didn't really save a whole lot of typing because I still have to type this whole thing here. All right. So for exceptions, I tend not to import those, although you can if you want. All right, so let's try it out. We compile it. Box of string b equals new box of string b dot get 12, and it's going to return an index out of bounds exception. Notice there's no number here, and that's because we didn't supply an argument to the constructor. And so that should convince us that what it's doing is it's throwing our exception, not the one that's built into arrays that throw the ones we had before. And I can further prove this by having our code, let's have it not throw array index out of bounds exception. Let's have it throw an exception that we created. All right, we're programmers here. We can make our own exceptions. All right, so let me recap first, and I'll show you how to throw that different kind of exception. So look for the conditions under which your program should generate an exception. In this case, if the index is negative or it's beyond the end of the array. And then you say throw new, because you're creating an object, and then the name of the class, array index out of bounds exception. And then inside the constructor here, you could pass in a string, the string is what appears right here. Okay, so I could actually put in blah right there. Let's do this again. And then there's our blah in the exception. So that's how that 12 got there. All right. So you could pass in to the constructor, you could pass in a string that contains the element number that you tried to access. And then your error code, your error exceptions will look just like the ones that Java generates. Okay, but I was going to show you how to make your own exception. So let's make a new class, and let's call this banana. Okay, public class banana extends RuntimeException. So RuntimeException is a class that already exists in Java. All we're doing is we're taking that RuntimeException and we're making our own class called banana that inherits everything from RuntimeException. So it is, in fact, a RuntimeException. That's all we have to do. And then in our program, we'll say it throws a new banana. Okay, compiles just fine. And let's go here. Let's make our box, and let's try to get what's inside of box 12. And we say, there, it just threw a banana at us on line 21. All right. So there you go. We just made our own exception. We called it banana. It extends RuntimeException. All right. And then in our program, where we had the throw new array index out of bounds exception, we just say throw new banana. Remember, banana is the name of a class, so we need to make an object from it and then throw it. All right. So how can we catch the banana? So let's make another class. I've got to come up with a name for this class. Let's call it, well, since this is holding an array of box is holding an array of something, let's call it, I don't know, gifts. All right, boxes hold gifts, right? Public class gifts, and I'm just gonna put together something really, really simple here. So let's go public void put gifts. Okay, so I can say box of string b equals new box of string. This is essentially what I was doing on the code pad. B dot set 0 hello. B dot set 1 by, oh, these are supposed to be gifts. So let's put in here Legos. And let's put in here, oh, that's a trademark thing. I can't do that. Let's put in here robot. And let's put in here toy car. And B dot set to doll. All right. So I'm putting three gifts into my box. And then let's say I want to go system.out.println b.get 0. Oh, let's do this. Let's make a loop. I like that. For int I equals 0, I is less than 0, 1, 2. So I is less than 3, I plus plus system.out.println b.get I. Okay, so it's just going to print out everything inside the box. Okay, good. So now we should be able to go gifts g equals new gifts, and then g dot, what was it called, put gifts. Okay, and there's robot, toy car, doll. Well, this stuff down here below, those were the exceptions that were generated earlier, so that's not being generated by our program right now. In fact, we can go and we can clear out this whole thing, and then we can do the same thing again, and we can see that it prints out robot, toy car, and doll. So it's showing us the 3 gifts that we have inside of our box. But let's say we made an error here and we accidentally made that a 4. So it's now going to attempt to print out everything inside the box, but it's going to go off the end of the array. Oh, sorry, let's not go, let's 4. Let's go like 11. Or probably an even more likely scenario here is you do something like that, right? So we know the length of the array is 10, but instead of using less than 10, you use less than or equal to 10. So we're actually going to end up walking off the end of the array. So let's do this again, put gifts, and we can see that it printed out robot, toy car, doll, and then a bunch of nulls. And my example is kind of lame here because I have a whole bunch of empty boxes, but it did throw that banana exception when I attempted to look at slot number 10. All right, so that's a problem here, right? So we don't want our program to crash necessarily just because we did something stupid here. What I'm trying to show you here is that I want to take that banana exception that's being thrown by it, and instead of the program crashing, I could maybe print something out. So the way to do that is you take the code that's possibly problematic, like this one here, and you wrap it up inside of what's called a try-catch block. Okay, so you're going to try to do this. And if this statement returns or throws an exception, you're going to catch it and do something else. So the way you catch it is you put inside parentheses after catch the type of the thing that's going to be thrown. In this case, it's going to be a banana, right? Our get could potentially throw a banana exception. So we're going to catch the banana, B, and in this case, we're not really going to do anything with it. So we're just going to say system.out.println no such gift in box, and let's have it print out the value I so we can see what the value of I that's generating the problem. And we'll compile that. And I can't call it B because I already have a box called B, so let's call this lowercase banana. Okay, so we're going to catch a banana, something of type banana, whose name is banana. hope you can see that there's a difference there. And then we compile it. And then let me go over here to this output here. Let me clear it so that we don't have any output that's confusing us. And now you can see it didn't generate the exception at all. Now it just says no such gift in box 10. So we successfully caught the exception that was being thrown. And instead of printing out that big error message in red, we printed out a nice error message to us that says there's no such gift in box number 10, which lets us know that we tried to access box number 10 and there is no box number 10. Okay, so that's how you handle exceptions, is by wrapping up the code that could generate an exception inside of a try, and then you catch the exception that is going to be thrown and you do something else, like print out an error message, or maybe this could loop back and reprompt the user or something like that. Okay, so that's the basics of exceptions. And so what I hope you see here is we did a check to make sure that the index was in a valid range. And if it's not inside of a valid range, we threw an exception. And here we defined our own exception called banana. And it's as simple as, let me got to bring it up again here. It's as simple as making a class with the name you chose. It extends RuntimeException. That's all you got to do. We're just making a class that extends RuntimeException. And then you throw an object of that type, in this case, banana. And then when you want to catch the exception, you wrap the problematic code up in a try block, which I'm going to highlight here. And then your catch block contains the exception that you're expecting to get back, in this case, banana. You can give it a variable name, and then you can do something else. Now, notice here that we're passing in a banana type, and we're going to call it banana. So inside of this code here, we could potentially do something with that. Like inside of the banana exception object, there's various fields that you can use to find out what went wrong. Like you can pass in messages inside of the exception. You can look to see what like line number it occurred on and things like that. So there's things you can do with this object that's more than just simply printing out an error message. You remember how it printed out in that big red thing about what line number it appeared on? That information is in the exception, so you can get that stuff out of there if you want. All right, so that's the basics of generics and exceptions. So you can use those techniques in your programs to make them a little more robust. In this case, being able to store something of a given type and have the compiler check to make sure you're storing the correct things. And you can also have your program throw exceptions, and you can have it catch those exceptions and do something with it. Okay, so at this point, I think I've covered everything I want to cover. There's a chat on YouTube, and I haven't seen anything posted this hour. So I'll wait a few seconds to see if anyone posts anything, and if not, I'll wrap this up for this evening, and I hope to see you next time. All right, I don't see anything coming in, so have a good evening, and I'll see you later. Bye-bye.